In this video, we are going to do function applications. We are going to analyze real-world graphs using the knowledge that we already had. So in A, it says, how far away is the park from Tommy's house? So it says in the directions up here, it says the following graph represents Tommy taking his dog on a leisurely walk from his house to the park, then back home. So I would hypothesize that he's starting at home here. He gets to the park here, and then he comes back home here. So roughly how far is the park from his house? So let's zoom in here. And it looks like this is about here. So I'm going to trace this back. 1, 2. So I'd say about 2.3, 2.4, something along those lines. And they are telling us this graph is in kilometers. So they're saying right here. So I'd say 2.3 or 2.4 kilometers. The next question said, what is f of 10? Well, remember f of 10 means that x is 10. So here's where x is 10. Here's where it hits my graph. 1, 2. Ooh, I need to zoom in. 1, 2, 3, 4, 5, 6, 7. So this is about 0.7. So 0.7. And then what does this mean in the context of the situation? Well, our x stands for minutes. So it would mean at 10 minutes, Tommy is 0.7 kilometers away from home. So basically we're going to take our two numbers and then put it in a sentence using our labels. When does the graph increase, and what does this mean in the context of the situation? So the graph is increasing from here to here and then here to here. So the graph is increasing from x is 0 to x is 30, and then from x is 40 to x is 45. So it's increasing from 0 to 30. And 40 to 45. And what this means in this situation is that from 0 to 30 minutes and 40 to 45 minutes, he was, you could either say walking towards the park, or if you said walking away from home, I'd be okay with that too. In D, it says, when does the graph remain constant, and what does this mean? Well, my graph is constant right here from 30 to 40. So what that means is from 30 to 40 minutes, he wasn't walking. Or you could also say he was taking a break. I also did not realize there's also another spot right here. I would say from 55 to 60. So from 55 to 60 minutes. So he wasn't walking, or you could say he was taking a break. So in E, it says, how long did Tommy take to complete his walk? So the total time, well, first he walks towards the park, he gets to the park, then he's going to walk home. So once he gets back home is about right here. So let's see, 61, 62, 63, 64, 65, 67, I would say. So it took him about 67 total minutes. We're going to do the same thing now, but with this graph. So the following graph represents the path of a basketball thrown for a 3-point shot. X is the distance and Y is the height. So X is my distance in feet and Y is my height in feet of the ball. So it says, what is the maximum height? So I'm going to look for the highest point. I would say it's about right here. Now let's figure out the scale. If this is 10, well, it can't be by ones. Let's see if it's by twos. Oh, it does look to be by two. So 2, 4, 6, 8, 10, 12, 14, 16. So it'd be 16 feet high would be the maximum. It says, question B says, if the shot was good and a 3-pointer was scored, what was the height of the rim of the basket? Well, that means the ball would have gone in right here. You can kind of see it changes trajectory there. So that would have been the height of the basket. So that would have been 10 feet. So we could say our hoop is like this. C says, in the context of the problem, which part of the graph has the greatest rate of change? So at the very end, I would say from here to here, this is the steepest part of the graph. Therefore, that is going to have the greatest rate of change. So we're going to say at the end, when the ball goes through the basket. The rate of change decreases quickly. All right, D says identify increasing and decreasing intervals. So if I'm looking, and if my maximum is right here, that means it's going to increase up until that point, and then it's going to decrease the rest. So my graph is increasing from X is 0 to X is 12. Oh no, this is 12, that's 14. Sorry guys, I forgot it was by twos. This is 12. This is 14. So it's going to increase from 0 to 14. And it's going to decrease from 14 to, well, it hits the ground, 22, 24, 26, 28, so about 27. And so what does this mean in the context of the problem? Well, when the ball is increasing, it means the ball is thrown upward. And reaches a maximum height of 16 feet. And then when the ball is decreasing, well, the ball goes downward through the hoop and hits the ground. All right, this lesson says explain in words what y 24 equals 12 means. Well, again, this would be the point 24 comma 12, meaning x represents 24 and y represents 12. So remember, x is our horizontal distance and y, so x is our horizontal distance and y is our vertical height. So what this is telling us is that horizontally the ball went 24 feet and it was at a height of 12 feet. So what it says at a distance of 24 feet, because that's what our x represents, from the player who threw the ball, the ball is at a height of 12 feet above the ground.